Parent functions. This is a shortcut that lets us tell what is the shape of a graph without doing the t-chart or without doing a bunch of arithmetic calculations. It's a pretty good shortcut, and just by using the shape of the graph, this kind of gives us all sorts of things like domain, range, and behavior. We can use this for a lot of stuff. All right. So parent function, it's just the simplest version in a family. And in general, you need to know what does it look like, right? You don't have to memorize it, but it's important to remember what the shape looks like at the end. Okay. So what I mean by that is, if I gave you a function f of x equals x squared, and I asked you to graph that, the Algebra 1 high school freshman way, the way to do this would be just to pick some points, some easy points like 0 is easy, 0, 1, 2, 3, and then also some negatives, -1, -2, -3. So I would pick some x's, some x points, and I would use the output from these to graph the function. All right. So let's go ahead and do that. Let's do it the hard way first, and then once we get the shape, we could use the shape to be the shortcut. So what I'm doing here is I picked some easy points, 0, 1, 2, 3. You can use whatever x value you want. You'll still get the same answer, but I try to keep things easy. So just running these through the function f of x equals x squared, -3 squared, -3 times -3 is +9, right? Or -2 squared is +4, -1 squared, +1, 0 times 0, just 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, all right? And that's really enough. We could keep going from there if you wanted to, but that's going to be enough to tell what's the shape. So here's -3, 9, -2, 4, right? 0, 0, 1, 1, 2, 4, and 3, 9. So just plotting these points, the x and the f of x, or y. Remember, y is the same thing as f of x. We can go ahead and connect the dots here. Ooh, I think I could do better than that. All right, so we connect the dots, and we're going to get our parabola from these dots. And you might have already known that just by looking at the f of x, x squared. You might have already known that. But this is going to give us a parabola. So the parent function, x squared, the shape of that graph would give us a parabola, kind of this U, the U shape. So for the next one, this is f of x equals square root of x. So again, just want to use some easy numbers here. I'm going to use numbers that are easy to square root, like 0 and 1 and -1. 4 is easy to square root, 9 is easy to square root, and let's do -2. So just typing these in, like if I take my calculator, I type in square root of -2, that's going to give me an error, right? I can't square root a negative number. Same thing if I type in -1, press the square root button, that's also going to give me an error. So these first two I really can't do. After that, the square root of 0, that's easy, 0. Square root of 1 is 1. Square root of 4 is 2. And square root of 9 is 3. All right, so the first two, I can't plot these. There's not going to be anything at -2, -1, but 0, 0 is right there. 1, 1 is here. 4, 2, and 9, 3. So that's really all I can plot. I could also keep on going if I wanted to plot more points, but this is enough to tell the shape of this graph is really just one curve starting at 0, 0 and going up. So these first two, we can't plot those because they just don't exist. They give us errors. So if I asked you for the domain and the range on this one, let's say D for domain, what are all the x values? Well, I can't do -1, -2. I really can't do anything negative. So x would have to be greater than or equal to 0, right? I couldn't do these. I could only do, 0 and up. And same thing for the range. So capital R for range. What could I make y? Again, same thing. Y gave me errors for all these negatives, so y could only be 0, 1, 2, 3, and beyond. So y would have to be greater than or equal to 0. All right, going back to number 1, the domain and range for this, we didn't have any restrictions, right? X could have been anything, negative, 0, positive. So X was all real numbers. And for that, I'm just going to use the symbol for all real numbers. It's a capital R with a line through it. And same thing for range. Just looking here, we didn't have any restrictions on the range. It could have been 0, it could have been over here, positive. But you notice that I didn't get any negative numbers for the range, right? It was always positive, 1 and 1, 4, 4, 9, 9. So the range for this was y had to be greater than or equal to 0. There was no point where I got a negative number for y, all right? So that's kind of how we can use the shape of the graph of the parent function to get domain and range. Let's do 2 more. So number 3, a little trickier on this one. So this is f of x is equal to the cube root, or the third root of x. So as I go through, I want to pick numbers that are easy to cube root, like 0 would be easy, 1 and negative 1. Or I know that 8 is a cube. I know that 27 is a cube. So really, I'm just picking easy numbers. You can use whatever you want here, and it's going to give you still the same shape. But I just try to pick things that are easy to cube root. All right, so first of all, the cube root of negative 27, that gives me negative 3. Right, it's not positive, it's negative. For negative 8, if I cube root that, that's going to give me negative 2. Negative 1 gives me negative 1. The cube root of 0 is 0. And then kind of the same thing going the other direction. The cube root of 1 is just 1. Cube root of 8 is 2. And then 3. All right, so these can be my points. And the first thing you might notice is these, I can't really graph that. It's going to be, way over here. Negative 27, negative 23 could be way over there, way off the graph. But the next one, negative 8, negative 2, I can plot that. Negative 1 right there. And 0, 0, 1, 1, and then 8, 2. And then the next one, 27, 3. Again, that's going to be like way over there. So let's just skip that one. But this is enough. You can sort of tell that you have a curve down there, and you'll have a curve up there. So that's enough to tell what's the shape of the graph. And that's all that we really care about. Once we know the shape, we can really just skip this whole part because, again, you don't have to memorize all this. You just need to know, what does the shape look like? And from here, I can get domain and range again. So the domain, x could be any number, negative, 0, positive, doesn't matter. X can be all real numbers. And for the range, kind of the same thing for the range. So y was also negative, it was 0, it was positive, there was no restrictions here. So y is also all real numbers. All right, again, that's kind of a bad job, but that's the symbol for all real numbers. It's that R with a line through it. All right, let's do the last one here. This one, you might have seen this before. I know that we talk about this in pre-algebra and algebra 1. So f of x is equal to the absolute value of x. That's what these lines mean, absolute value of x. So again, I'll just pick some easy negatives, small numbers. 0, I'll pick some easy positives too, 1, 2, and 3. And you can change this. You can do whatever x you want. We'll get the same shape at the end. So absolute value just means what is the absolute distance that number is from 0 on a number line. So how far is negative 3 from 0? It's just 3, positive 3. Or how far is negative 2 from 0? It's just 2, positive 2. Same thing for this would be 1, 0 is 0. And then these are also going to be their positive distance also. So 1 is 1, 2 is 2, and 3 is 3. So no matter what, negative, 0, positive, no matter what happens, I always get a positive output. So when I go to plot that, negative 3, 3, negative 2, 2, negative 1, 1, and then 0, 0. As I go to plot those, you can sort of tell I'm getting kind of a V shape here. 1, 1, 2, 2, and 3, 3. All right. So I'm going to connect these dots so you can tell the absolute value, the parent function here, is giving us just kind of a V shape. For this one, domain and range, let's look at the domain. I could make x any number. It could be negative, 0, positive, right? I've got x's over here, over here. So x is, again, all real numbers. But for the y, you might notice as I do the range, the y, I never got anything negative. It was only positive or 0 and then positive again. So y had to be greater than or equal to 0. All right, so that's pretty much it. These are the 4 main parent functions that I'm going to be looking at. There's others too. There's more than this, but these are kind of the most important ones. So in my next video, we're going to look at how we can transform these, how we can move them around the graph.